Okay, we are back again for round 2 of this. Let's see, and I've begun recording this, so this will be the video that will be uploaded for today's lecture. We won't spend a great deal of time on this. One of the things that I just wanted to make sure to cover in today's lesson was kind of finish up on the normalization stuff, but then not at least to the third normal form. It's kind of rehash that a little bit because I want to make sure we don't rush through that because of how important this whole normalization process is in terms of designing a good database. But then also I've gotten a few questions related to the group assignment, the group project that is due. It was originally due last week and now is going to be due, or I guess earlier this week, and then now it's going to be due a week later. So I want to go ahead and discuss a few things about that because under the new situation, there's going to have to be some changes to how we were planning on finalizing that thing. So actually, if we just talk about the whole normalization process, again, the whole idea of what we're trying to accomplish is we want to get rid of data redundancy and what we call update anomalies. So in the example that we showed, what was that, Monday? Yeah, the example that we showed on Monday, there was we went from 90 cells that held data to something like 67, 65, something like that. And I could pull that up again, I guess. But the thing that I wanted to point out there was that there was a lot of redundancy in our data. There was a lot of information that was repeated that, it's one of those things that in today, we don't necessarily think about that as much because of how much access to large data things we have. So, when databases were first becoming used, especially relational databases, we didn't have a whole lot of space to deal with. So we had to figure out ways to minimize how much space we were using. And it seems like now when you can hold gigabytes and even terabytes, hundreds of gigabytes and even terabytes of data in the palm of your hand on something the size of your thumb. It's sometimes we think, oh, we have tons of space. We don't have to worry about the space stuff. But one of the other aspects that we don't necessarily think about is how the redundancy, not only is it takes up more space, it also makes it harder to search through things. And so it ends up costing us speed as well. So that's why space becomes important. But then the other important part of that is that whole update anomalies. The example that we showed back here was in the dream home example was what happens if here this branch B003, their address gets changed, or someone goes in and changes the address, or puts in a new employee at branches B003 and they put in the wrong address in this table. Well, now you could have different rows, both with the same branch number but a different branch address, and that's going to be a big problem because then we don't know which data to trust. We don't know which one is the correct information. And so if we store stuff like that in a single spot, one time only, that way we know we have the most consistent, most current information. And if someone adds a new employee, adds a new staff person over here at branch B003, then all they have to put in is the branch number. They don't have to put in the address, and so there's no risk of them putting the wrong address in. And so we don't have to ask that person to enter that information. Okay, so by way of review, so that's the why. That's the why we go through this whole normalization process. And then, the more what we, as the developers, as the database programmers, what we're going to be mostly in charge of too is going to be the how. The how do we go from an unnormalized form into a normalized form, into a deeper and deeper normalized form, right? So we talked about taking an unnormalized data set, right, and using our data information, our example data, and uh, identifying functional dependencies. And remember, functional dependencies just were one column or a set of columns like A, B here that determines the value of another column or set of columns. Okay, and we want to have a full set of functional dependencies. We want to have every column represented at least once in a functional dependency. All right, so we want to have every column somewhere in. And the way we would identify for a functional dependency is we would try to find one where some column or set of columns over here appears on the left side, and we could put every column in the entire table on the right hand side. So we have A and B is going to determine all the other columns. Okay, we won't get into this today, but one of the things we talked about on Monday was I said that because A was over here, it meant that anything that is only dependent on A could also go over here. All right, so C could go over here. Then we also said the same thing. B is over here, so anything that only is dependent on B could also go over here. And what you end up with is you end up with the combination of columns A and B determines all other columns in our table. Okay, and so that would make A and B a candidate key, and then because it's the only candidate key, it also automatically becomes the primary key. So we'll talk about on Monday when I get into the advanced normalization lecture, the chapter 15 normalization lecture. We'll talk more in depth about why this is and what we call this. There's some identities, kind of like math. Math has identities. You know, the 1 times anything is that thing, 0 times anything is zeros, you know, and digital logic has identities as well, you know, and or and stuff. Well, in our functional dependencies are also going to have identities that we'll talk about. But for now, just know that anything that if I can put this on one side and this on one side, I can do if B is part of something on the left hand side, then I can put it over here. Also, if B were on this side of some other functional dependency, then I could also put D over there as well. Okay, so let me revert this slide back to what it was before so that it doesn't mess up. Okay, all right. So we identify a primary key. So we're going to have, what we're going to get to is a point where we have a table where every column row intersection, so every cell has a single value in it. We're going to identify a primary key, and what we call that is we call that the first normal form. So once we get to a first normal form, we can start applying our normalization process from then on using that first normal form table. Okay, so we're going to get stronger and stronger, and like I said, your group project, and as far as this week is concerned, I want you to be able to understand the differences between an unnormalized data set, something, you know, this thing out here. What does first normal form mean? What does second normal form mean? What does third normal form mean? Get into these other ones, the others. We'll get into that on next week. We won't introduce that this week. Okay. So we've just mentioned what the first normal form was. All right. So basically, UNF to first normal form, we just get rid of repeating groups. We make sure every cell has a piece of information in it or a null. It could be null if it needs to be. And then we also identify a primary key. Okay. So getting into second normal form, this was basically the whole full functional dependency. Every column in our table, in any table that's in second normal form, is either going to be part of the primary key, or it's going to be fully functionally dependent on the primary key. All right, and so what that means is if there is a partial dependency, if there is some column in our table that is functionally dependent on the primary key, but it's functionally dependent on the primary key because it's functionally dependent on some subset of the primary key, then we don't need the whole primary key for that. We don't need to keep that column in our table. We can move it to its own table, and we can use the of the primary key that it's dependent on, use that as the new primary key for the second table. Okay, so if I switch back over to, let's see, where did I have it? You know what? I closed it out, didn't I? Let me reopen it. Where are you? Come on. Come on. Hold on a second. Let me try to figure out where it's gone. Okay. Let's see, 204. Could be the live streaming is slowing down the internet, so Google Classroom is taking longer than normal. Okay, let's see. It's not opening for some reason. Come on, Drive. Okay. Okay, there we go. That's what I was looking for. Okay, let me go back and share this again. Okay, so if we remember from the Monday lesson, this was we immediately could look at this data set and know that this is not even in first normal form. And the reason why we know that is because depending on how you want to define what a row is. So if this was the Joseph Leday row, for example, then what you would see is that and this column, there's two values here, and there's two values here, and there's two values here, and so forth. So what we need to do is we need to make it to where every row, every column has only one value in it, every intersection of a row column. So here, or if you want to look at it this way, you can say if this was a row and this was a row, then what you have is, well, you know, this value, this cell right here doesn't have a value in it, but it needs it. We would look at this information and we would say, well, clearly this part of goes with the Joseph Leday information. So what we need is we need to make that information, we need to copy that into this part right here. And so that's what we've done in this first normal form here, is we've copied that into this part right here. Okay, and if you notice, there's no repeating rows. There's no, we can't find any row where it has all 9 columns have the same information as any other row. Okay, so now we have this table in first normal form. And then to get into second normal form, the problem was these two columns, right? These two columns, that they are dependent on the primary key, the AF combination, but they don't need F. I don't need to know what F is to know what this information is if I already have this, right? So I really just need the A column. It determines what B and C are. So this is what we would call a partial dependency. It's not fully functionally dependent on the primary key. It's partially dependent on just A. So I'll break that out into its own table here like this. All right. And then the third normal form. So if we're getting into what the third normal form is, it's the idea of the transitive dependency. So if for this the second normal form, every column is fully functionally dependent on the primary key, the transitive dependency just says there are some columns that they may be fully functionally dependent on the primary key, but they're really, if we really look at them, they're really just dependent on some other column, right? So yeah, it's fully functionally dependent on the primary key. I can't just look at this and get this information every time, right? I can't just look at this and get this information every time. Let's see, 123, well, what's the drug name? Well, it depends. Which one am I talking about? Which date am I talking about? Okay, 20th of March, which drug are we giving? Well, there's a couple of different options. So clearly this column is fully functionally dependent on the primary key, but really it's fully functionally dependent on the drug ID column, right? And so we can do the same thing we did here, where we take this and we make it its own table. So we get rid of transitive dependencies, making an employee table, making a drug table, and I'm actually going to change this live here. And so we actually don't want the column names necessarily. Okay. And so now we have an employee table. We've drastically reduced the redundancy. We have greatly reduced the amount of space we're taking up, and we've gotten rid of we are no longer susceptible to update anomalies. If for example here, if somebody comes in and says we're going to change the name of this to something else, okay, well, the problem is it's that here, but it's something else here. That's a problem, right? We can't do that in the third normal form here. If we take this and we make it something else, it's going to be something else for every time the CV1 value appears. Okay. All right, so that's, again, a refresher on the whole normalization process. And a few of you have asked questions about this, okay, about your group project, right? So what I kind of want to do is I want to talk about your first submission, but I also want to go ahead and have a discussion. My expectation is at this point that we will probably not be able to have in-person presentations for the final group project. So what I would like you guys to do is I would like you to record a video. Now, all of you have access to this Microsoft Teams by the fact that you're on here and you're listening to me talk right now. And what's neat is I'm recording this right now. So what we could do is maybe not a live presentation, but you could, since many of you are probably not in the same physical location with each other, with the rest of your group, what you could do is host a group meeting. I'm assuming that all of you have access to be able to create a team in the Microsoft Teams application. And what you can do is you can create a team that consists of your group. And then what you can do is host a meeting that you could record, and then each of you take turns giving the presentation, giving parts of the presentation. We'll talk more. What I'll do is I will give you some more details of what I would expect from your group to be able to do that, like what I would expect from the individual team members. But just as a kind of a heads up and kind of be thinking about is how you could maybe make a group video-based presentation. Okay. All right. So what you're going to do, what I want you guys to do is I want you to kind of follow a similar process to what we did here. Okay. So I want you to start off with this UNF or first normal form database. And what you're going to do is you're going to give that to me. You're going to show that in some type of list of data items, a set of data in a grid or a spreadsheet. So if you put this, right, if you put this into a Google sheet or an Excel spreadsheet, or even just a table format in a Microsoft Word document or a PDF, that would be fine. So this with 30 columns, 30 or more columns, would satisfy the first requirement, okay, the first part of your group project. All right. Now, you're probably going to need to go through this process of normalization before you start drawing your diagram. Because if you draw your diagram starting with the unnormalized set, it will just be one table, right? It would just be a single table with a whole lot of attributes. And so instead, what we're going to do is you're going to follow this normalization process, taking this, bringing it along the way into, right, this other format. Right? And then what you'll do is you'll take the tables you created here, and you can do this, right? Okay, you can create this diagram. Now I use this draw.io, and I think it's I got a notification that it said that it's actually called diagrams.net now or something like that. So so you can use this. It's an online free tool. You can connect it to your Google Drive so that you can save your drawings there, and then you can create your diagram based on what tables you have here. Okay. Now, sometimes this diagram, like for example, you may have something like this. So you may end up, let me pull it down here, this here. You may end up with like a table between two other tables. Like you may end up with a student in a certain semester takes a course, right? You may end up with something like that. All right. And it may be a one-to-many and a one-to-many relationship, right? That's okay if you represent like this. And it is also okay that if you take one look at that and you realize, you know what, actually, that looks more like just a many-to-many relationship of a student taking a course, and it just so happens to have attributes on it, right? So the way that we could show that is with this whole dotted line. Let me see, where am I dotted? So if you could have like a dotted line, actually. So you could have like a dotted line here that would have attributes, right? So attributes of this. So what semester is it? You know, and when a student takes a course, they might also have a grade, right? So you can draw it this way, or you can draw it as a table between other tables. Whatever makes the most sense to you, you should go ahead and do that. But be prepared that whatever notation you use, that you'll want to be able to explain your choices. So, for example, if I get back out of this, for example, over here, right? So here I have a one-to-many relationship. A patient to the patient to the trial looks like it's a one-to-many relationship. Now, there's a couple of things I want to note here. You don't have to use both the numbers format and the diagram format. Okay, you don't have to use them both as I've shown here. All right, but whichever one you use, you need to make sure you understand what it means. So you need to understand what 1 dot dot 1 on this side and 1 dot dot star on this side means. You need to know what these two lines means the same thing, 1 and 1, and what this kind of pitchfork fork looking thing means over here. Okay, so the way that we would read this is that patient has a one-to-many relationship with trial, mandatory participation on both sides. What that means is that if we have a patient, they must be included in at least one trial and can be included in many trials. If we have a trial, it must have one and only one patient associated with it. Okay. This, by comparison, is different. This employee has a one-to-many relationship trial, mandatory on employee, optional on trial. And what that means is that if there's a trial, it must have one and only one employee that has administered it, one and only one employee associated with the trial. If we have an employee, they can administer many trials, but they don't have to have administered any of them. Okay, they don't have to have been involved with any trials, but if they are, then they can be involved with many trials. Okay, so make sure you understand the difference between some of these different types of relationships. So if we look at, like, what does many to many mean? What is, let's see, that one we already have an example. Okay, like what is a one to one mandatory optional? What does that relationship mean? All right, that one's one we have already. Okay, what does it mean if we have this type of relationship? Okay, a one-to-many relationship where it's optional on the one side, mandatory on the many side. Okay, and these just mean different things. This means something different from this. Okay, and again, if you want to show it using this diagram notation, that's fine. If you want to show it using the numbers notation, that's fine. But I want to make sure you understand the reason why I'm going into this so in depth is because when you submit that first submission, that first group submission, you will be asked about some of these, especially if I'm not quite sure I agree with you, or if I don't understand necessarily why you chose that, or if I just want to see, do you know why you chose that? So for example here, let's say we wanted to show the relationship between a professor and a course. So let's say that in this example, we're going to assume that a course is represents a specific class in a specific semester. Okay. Now the way that we might say is, okay, a professor can teach many courses, but a course can be only taught by one professor. So we would assume this could be a one-to-many relationship. Okay. So we might say it's a one-to-many. Let's put it back on. Okay. Okay. So now we have this one-to-many relationship. Now, I've made this optional on this side. What does that mean? All right. So the way that we would read this is that if a course exists, it must have a professor and only one professor teaching it. If a professor exists, he or she does not have to be teaching any courses, but they can teach many. And what we might do is we might say there's a limit on here. There's a, let's see if I can use this to make a text box. we might say they can teach 0 to 4 courses. They can teach 0 courses, they can teach 1, 2, 3, or 4 courses, but we don't want them teaching any more than that. Okay, so what does it mean for a professor to have an optional, that the course is optional in this relationship? It simply means that if a professor exists, they don't have to teach a class. Okay, professors can be lazy and not teaching? Well, no. What we might say is in a specific semester, they may be focusing on research, or they might be taking a sabbatical. There's all kinds of possibilities why a professor might not teach a course in a given semester. And so in this, what we're saying is we're going to allow for professors to not teach courses in a specific time. Okay. What we could do is we could say, and someone might come along, and a customer might come along and say, no, 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 we always want them to be at least teaching a course. And what we'll do is if they're taking a break, if they're taking a sabbatical, if they're taking research, we'll put them into we'll have a special course for that, and we'll call it the research course or the sabbatical course, or something like that. But we always want them to be listed as teaching some class. So they always have to be teaching some. Can change the type on this eye to be mandatory mini, which would also mean this would have to change as well. Okay. But then what does this mean? So and what I want you to be able to do is when you choose your relationship between two tables like this, I want you to be able to explain what that means. And for anything that's like a choice, right? It could be mandatory. It could be optional. It could be a many-to-many relationship where is it optional? Well, if a student exists, they don't have to be taking any courses. What does that mean? If a course exists, it doesn't have to have any students in it. What does that mean? I want you to be able to explain those, what we would call those design decisions. So these systems out there are all full of design decisions that when they were made, when Apple made its computers and its iPhones, when Microsoft made its computers, when Samsung's making their phones, there's all kinds of design decisions that have to be made. And there's oftentimes not one right way to make something or to do something, but we need to be able to justify, we need to be able to explain why we decided to do things a certain way, especially when there is a list of options available. And quite frankly, you're almost never going to encounter a situation where you make a design decision and you please everybody, right? The fact that some people love Apple products and can't stand Microsoft, and vice versa, the fact that some people love Microsoft and can't stand Apple, and some of us use Linux and that we don't like Apple or Microsoft. And the whole reason is that we don't agree with whatever the other guy did to make their product, right? We like the ones that we like because they made design decisions that we mostly agree with. So you need to be able to, when you take a look at your system that you're designing and you say, this is how I want it to be made, and this is the type of relationship I want between these two tables, you need to be able to explain the why did you choose to do it that way. Okay. So you're going to take these tables like this, draw them into an ER diagram. Let me suggest that you do use something like a draw.io, something like this, or some other product. If you draw it by hand, especially if you draw it by hand on paper, it becomes really hard to edit. Whereas with like a draw.io like this, if I make this connected to here and make this connected to here, if I want to move this to somewhere else on the page, notice that relationship follows it. So it's really nice to be able to move it around and put it into a different place and be able to make changes like that without having to erase a lot or redraw things a lot. Okay. All right. So that's number 2. Then number 3, you're going to need those SQL queries. We went through an example let's see, I went through the example for the vaccine example here, where I took these data items, I put them into a MySQL database, and I wrote the queries. Just go ahead and put those into the text of your document, right? So you just need to put those SQL queries, the create table queries, the insert into using the select from, and then make sure you use the select distinct. Then I want you to also make sure that you include the creating your foreign key constraints, right? So you're going to need to probably alter table. You're probably going to create a table, put the data in, and create, and then alter table using a foreign key constraint. And then I want you to drop columns from any from your UNF table that that didn't exist before, right? So you want to drop the tables, drop the columns once you take that data and move it into your second and third normal form tables. Once you do that, you need to drop the columns from the source table, from the UNF. Okay. And then finally, this last one's just kind of a fun thing of making sure that you can kind of put it back together. Because remember, the main thing that I've talked about in terms of this normalization and stuff is this format becomes really easy for a database management system to handle. It becomes very quick to search information, becomes very easy to store information. But if this was a separate table, like imagine each of these tables, the trial table, the employee table, the drug table, and the patient table, imagine they were all separate tabs on a spreadsheet. And let's say I wanted to ask somebody, can you give me a list of all the drugs and employees that Joseph Leday has, all the drugs he's taken and all the employees that have administered his trials? You know, if we had them all on separate tabs down here, it'd be hard for you to find it because you'd have to say, okay, patient 1, 2, 3. Let me go to the trial tab. Okay, so he took drug CV1. Let me go to the drug tab. Oh, that's COVID vaccine 1. He took that given by number 10. Number 10, that's John Doe. Right, so it'd be hard for us to be able to very quickly understand the relationship between all the trials that Joseph Leday was in charge of, right, or a part of. But if we had the format something like this, our human brains can look at this and understand this type of data much more quickly, right? And so what this last part, this part 4, what it's intended to do is for you to be able to say, can I take my third normal form database tables and put that data back together into a format that's more understandable for my human readers, for my human viewers, right? So you need to be able to create a select query that will take, basically it'll be a select with your 30 or however many columns you have, right? And then it will join the tables together in the appropriate way so that what'll happen is when you run this view, when you run the select query for this view, what you should get this back, right? You should see something that looks the exact same as this. Okay, so you can put all of this into one PDF or Word document if you want, where you have section 1 is a grid with all the data. Then you have then you have a diagram that's the ER diagram. Then you have a list of SQL queries that will create your tables, insert your data, right, and all that. Move your data around, and then a view. Just give me the select view that will recreate the original data set. Okay, and Basically, what this first part of your group project is it's basically the process that I followed in my first job as a programmer. That was a data migration that we did. We produced a program. I've talked about this before with you guys. We produced a program to maintain equipment for oil refineries, and what happened was that a lot of times their systems that each refinery had was very different. You had some that stored their stuff in Excel spreadsheets, some that stored in Microsoft Access databases. And what we needed to do is we needed to be able to migrate their source data into our system. And that's basically what you're doing is you're taking an unnormalized data set that your customer has given you. So whatever your project is, your music library or your hotel management system, just whatever it is that you're doing, right? They're giving you a set of data that they have. And man, it's bad, right? It's a bad format because it's just a bunch of rows, right? It's just one table with a bunch of rows, and your system is going to be much better to be able to handle that because you are going to take their set of data and you're going to normalize it into a database that your system can handle much more efficiently. Okay, so that's the plan. Let me unshare the screen and I'll go ahead and come back to the conversation. All right. So does anyone have any questions about, I'm hoping that should answer, some of you guys have written me privately to ask questions about what the expectations are and what the group project should look like. I hope this answers some of those. But now would be the time if you have any live questions that you think could help the rest of the class. I have the meeting chat up, so if you want to type them in or if you just want to ask them out loud, either way. Okay. All right. So if not, then what we'll do is we'll call that a day. So we'll go ahead and end the meeting here. I'll stop the recording. Okay.